Hello, Sean Sullivan, here to talk about GitHub Actions. So GitHub Actions is a relatively new enhancement to the GitHub platform. And I've been using it for the last 4 months or so, and I thought it was sufficiently compelling to stand on a stage and talk about it. So a little about my background. I'm an engineer, primarily write code day in and day out. I try to delete more code than I write. Doesn't always work, but I find that's the hallmark of a good day as an engineer. So over my career, I've worked for a variety of companies, from the retail sector to the semiconductor sector, and now I'm working for Twilio, which is a cloud communications platform. And one common thread through all the different jobs I've held is that we always had a lot of investment in build automation. Even, in fact, my very first job as a professional, when I was hired at Intel, they needed someone to automate a build for a project, and that was literally my first assignment. And it's really resonated with me, and so every new team that I join, the first thing I ask is, can I build the code, or do we have automation? So the agenda really is just to look at GitHub Actions, look at what it's capable of doing, how I've used it personally, some of the good and bad things that I've seen. And I imagine most of you are already using GitHub. Is that a fair assessment? So, GitHub Actions is really just an extension to what you're already doing. So there's just kind of a natural thing for you to learn and adopt. Now, when I was preparing this talk, I was trying to think, should I categorize this talk as like continuous integration talk or continuous delivery talk? And a lot of times you hear people use these two things, CI/CD, together. So I went back and I looked at Jez Humble and Dave Farley's book. And they didn't define CI as a specific tool. CI was more or less like a set of practices. And the most important practice of all is that your development team works on a main line, like a central trunk or master branch. And everyone on your team is frequently checking in to that main line or branch. And if you attended the keynote this morning, Jez talked about this specifically, and what he said was that you should try to check in your code to trunk daily. And in my experience, this is the most important aspect of CI, more important than any tool, is just having a team of developers who commit to this specific practice, having one central main line of code. And if you read further into the continuous delivery book, they made this reference. They said that the idea of continuous integration was actually written about long before in Kent Beck's Extreme Programming book in the first edition. So I dug around and found I had the first edition copy from 1999. And you can see here, this was one of the core practices that Kent Beck was advocating almost 21 years ago. And what's interesting about his paragraph on this here, it was actually a whole chapter, but this specific paragraph, he talked about continuous integration as something that a pair of developers do by walking over to a machine that is reserved for doing integration builds. And the two developers should sit down at that machine side by side. They should load their latest revisions, change set, and then run some build script, and then resolve any build failures. So it's important to have this occur daily, and it's important to always make sure that the tests are passing. And those are core practices that I've used at all the different companies that I work with. And so to me, it's adopting those practices, and that mindset is kind of a prerequisite before you adopt any specific CI tool. So GitHub Actions is really a tool that extends the capabilities of the GitHub platform. It lets you do more things, automate more things. It lets you be more productive, is how I look at it. And GitHub Actions was announced a little more than a year ago. It kind of like sat in preview mode, I think, for about 12 months or so. And then GitHub Universe, which was this past November, GitHub Actions was declared as a GA release. So if you participate in the preview before that, you know that it wasn't considered production ready at that stage, but as of GitHub Universe, it was announced as ready to go for the world. So Actions is a way for you to automate the workflows and tasks that you're doing in software development on GitHub. And so, for most developers, we all do code review. We are all opening pull requests, or reviewing code, closing out our pull requests. And that's the most common use case here as well. You open a pull request, you want to trigger a build off that pull request. You want to wait for that build to finish, and then view the results of the build. And GitHub Actions gives you that capability. But GitHub Actions is so much more than that. That's only one example of a workflow. And the other cool thing about GitHub Actions is that it's designed to be extensible. It has some built-in functionality, and you can just use that as is. Or if you want to extend it and customize it to do exactly what you need, you have that ability as well. So you can write custom behavior, which is known as actions. And then you can structure a sequence of steps into what's called a workflow. And you can customize the workflow however you like for your use case. And you can also customize actions if you wanted to build your own. So if you haven't seen it before, I just kind of want to walk through how you would set this up on an open source project. So I did this recently. I had a library on GitHub. It's open source. It's like a Scala library. And I built it out with some coworkers a few years ago. But we wanted to re-release this code. We're kind of rebranding it, repackaging the code. And so we wanted to modernize it, and we decided we would set up a build with GitHub Actions. So more or less what you would do, and any of you will see this today if you go to your GitHub projects, there's an Actions tab. And that is really just the entry point to setting up a workflow. Now, once you're on the Actions tab, GitHub will say to you, oh, we notice you don't have any workflows defined. Would you like to set one up? And what GitHub does is they actually look at the contents of your repo. They look to see what programming language you're using in that repo. And they will recommend a pre-written workflow for that specific language. So if you're using JavaScript or TypeScript or Java or Scala, they will prompt you to set up a workflow that they've already written that is specific to that language. So here on this slide, it just says set up this workflow, click that button, and then it opens up essentially the workflow editor. And the workflow editor is a way for you to, well, it is a YAML editor at its core, but it has autocomplete capabilities. It knows all about the syntax of a workflow file. So it knows what fields are required in a workflow file. It knows what fields are optional. It helps you do autocomplete of all the workflow content. But what's cool is that this workflow editor, when it opens up, it's already pre-populated with a fully working YAML workflow. And typically, when I'm setting up a Scala project, I actually typically rename the workflow. By default, they just call it scala.yaml. I typically am naming my CI builds with the name ci.yaml. Whether I'm doing a Java project or a JavaScript project or Scala, typically just name it ci.yaml. And then the next thing, if you start scrolling through the editor, you'll see that the workflow, this particular default workflow is set up to respond to a push event. So whenever someone pushes code to a branch or to master, that will be the trigger that activates the workflow. And so as a newbie, if you're just starting out, I'm just going to say, like, just leave this the way it's set up. You can always come back and customize it to do other things later. But the other thing is that after you've set up that, you've defined what event you're going to react to, then you can set up one or more jobs that you want to execute within this workflow. By default, this is set up with just one job. It's called build. That is just like an arbitrary key. You could rename that to something else. But we have a build job, and what this build job does is a couple steps. In fact, there's really 3 steps in this particular workflow. The first step is that it's going to do a checkout of the code related to the event that triggered this to occur. So it does a checkout. And then the next step, we say, I need to set up a Java runtime, like the JDK. So if you're doing a Scala project or a Kotlin project or a Java project, you're going to need to use this. Right here, setup-java is what it's called. So this is step number 2, is just setting up the JDK. And then step number 3 is I'm invoking my build tool. And because this particular library was written in Scala, I'm invoking SBT, which is the Scala build tool. And I'm going to run the test suite that I had already previously written here. And that's basically all this does. This is like the bare bones, simplest possible workflow that you could write. It's check out the code, set up Java, and then invoke the build tool. And that build command is running a test suite. So if you like the contents of the workflow, you just click Start Commit. And that opens up this other little window that gives you the option of either committing this directly onto master or opening up a pull request. And then you could have your teammates review the contents of the workflow. Typically, for some of my open source projects, I'm only working with 1 or 2 people, and I usually merge to master. But that is what I did on one of my projects recently, just merged straight to master. And you can see here that when the workflow editor is committing the file to my repo, it's also setting up a directory structure for my workflows. So it creates a subdirectory called .github, and under there you have a subdirectory called workflows. And that's where all the GitHub Action workflows are going to live. And GitHub Actions allows you to set up 1 or more workflows. It's kind of up to you how you want to structure it. Some of my recent projects, I've been setting up 2 workflows per library. I typically will set up a ci.yaml, and then I will set up a second workflow that I call release.yaml. The CI is just to run the full test suite, and then the release.yaml is basically to package everything into an artifact, assign it, and then publish it to like Maven Central. So after you have a workflow committed into your repo, you can look at the Action tab again, and you'll see that it will list all the workflows that it knows about. So this is the newly created one that I set up. And you can see on this slide that it actually executed. And they show that it basically ran my build command against the master branch, and it completed in minute 27. So if you're interested in like drilling into your build, you can just click on the build name itself, and that will bring up this display. This screen is where you actually are allowed to inspect all the steps as they executed. So if one of these steps had failed, I could drill in even further here and go look at the build error. So that is how you set up like the really most basic workflow. But I was looking around after GitHub Universe. I was looking around online to see like if any other like major projects were using GitHub workflows. And I think the best example I found was the Ruby on Rails project. They've set up a single workflow that executes on basically every pull request that comes into Rails. So if you're interested in Rails, go look at the Rails project. And they have a .github/workflows folder. And in there, you'll see they've already set up one workflow called Rubocop, I guess. I'm not a Rails developer nor Ruby developer. But inside the workflow, what they've done is they want this particular workflow to execute whenever there's a push to the repo or whenever someone opens a pull request. And that's more or less what that line is doing. The other thing that they have in the workflow is that they set up the Ruby runtime. And they wanted to set up a very specific version of Ruby to execute. And so much like you saw earlier, I was setting up Java. Here you're just setting up Ruby, and you specify the version of Ruby you care about. And then the other interesting thing about their workflow is that they enabled a caching step. And you see this in a lot of CI tools. If you're using like Circle CI, Travis CI, this is a common feature in a lot of these tools. It allows you to cache any dependencies that your build script uses. So if it's Java, you might have jar files. If it's Ruby, it's some gems. And so you can define very specific behavior of what resources you want to cache. And the advantage of setting up this cache is that it means that the first time you run it, it still has to load everything over the network. But the next time this workflow executes, likely it will go and try to load the cache from the cache using the cache key. And if it can find the content in the cache, it will just load that and use that. So it's just sort of an optimization, makes your builds run a little bit faster. All right, so we'll move on to just some core concepts about GitHub Actions. There's really three key ideas here, and I've kind of alluded to them already. But the GitHub platform generates events. And then an event can trigger workflows, and workflows contain steps, and some of those steps may invoke actions. The best way to explain it is that, think of it, as I said earlier, a pull request is really just an event that's occurring in the platform, but it's not the only kind of event that occurs on GitHub. People can create issues, people can add labels, people can add a tag and push a tag to a repo. Those are the most common events. There's also one called schedule, and this is where if you want to have a scheduled trigger that occurs on a certain cron schedule, essentially. So if I had something I wanted to execute every hour or something I wanted to execute every Sunday, I could pre-configure a scheduled event to call into my workflow. So workflow is just some set of steps, logical steps that you want to execute. It could be compiling your code. It could be generating documentation. It could be running like a lint command. It could be generating a code coverage report. It could be publishing the code coverage report to somewhere else. Or it could be that you want to publish artifacts to a Docker registry, or publish artifacts to Maven Central or some other artifact repository. Now, historically, GitHub has always provided you with a mechanism for getting these events. Traditionally, if you look at the API docs for the GitHub API, you'll see that the GitHub API allows you to register webhooks. So if you've been developing on GitHub for a while, you might have seen documentation that says, okay, I will register a webhook with GitHub and it will call me back when things are happening. With GitHub Actions, you almost don't have to set up these webhooks at all. And so for most use cases, you will not need a webhook. You'll just need to set up a YAML file that you put in your repo. And you can think of that YAML as kind of like a replacement for a post request. So instead of having a post request to an endpoint, GitHub is just directly loading your YAML and then executing everything that is contained in the YAML. And so actions are kind of like reusable components, some sort of logic, some body of code that you want to package up and make as a reusable set of behaviors. So if I had 3 projects and they all needed some common behavior across them, I might set up a central action that I publish, and then all of my different projects can all invoke that same action to get that common behavior. Now, what's interesting, as I said before, there are actions that are provided by GitHub. There are also actions provided by third parties. And then there are actions that you can write yourself. And I will say that on most of the projects I've done, I've just been using the core actions provided by GitHub. It's things like checkout, this setup, and the cache steps, the cache actions. I mean, those are the real 3 that I use pretty much on every project that I've been using. If you are interested in writing your own action, kind of the way you get started is by setting up an action.yaml file. So what you would do is you would create a new repository on GitHub, and you would add in action.yaml, and that there's a certain syntax for it, which I won't go into here. But the action YAML is where you define all the inputs, basically all the incoming parameters to your function, and then as well as any outputs that you want to return to the workflow. And if you are going to go this route and build your own custom action, there's really two ways of doing it. You can just write JavaScript code, add that JavaScript code into your repo, and then set up your action YAML to point to that JS file. And that is basically the simplest way to write an action. There's another way to do actions, which is through Docker, and that's where you would provide a Docker file in your repo. And this can be advantageous if you already had some other command line tool that might be written in some other language like Go or Python. You might just want to package that CLI tool into a Docker container and then provide an action.yaml that invokes the Docker container. And then the Docker container is where your Python or your Go would execute. And the other thing about GitHub Actions, I think they announced these details at Universe in November, but they've added the capability to most GitHub editions. So if you're on github.com, you can use it today. If you're using any of the other enterprise or team versions, there's support for running it there too. And I was working on an open source project recently where we needed to enable a CI, and we already had a tool in place. So we ended up just deciding that we would actually turn on GitHub Actions, and we decided that we could run it side by side with the previous tool. And so we had 2 CI tools running at the same time, which actually worked out fine. It allowed us to evaluate both and compare them and decide which one we wanted to move forward with. So that's kind of a good strategy. I recommend people consider that. But the other ideas around GitHub Actions are the concepts of runners and environments. Runners are basically the nodes where your workflow is executing. You can execute them on GitHub provided servers, or you can self-host the runners yourself. As far as virtual environments, Linux is supported, Mac OS is supported, and Windows. So there are some really high-quality third-party actions available. And if you run on any of the major cloud platforms, the good news is that all 3 cloud vendors here are actually providing these actions. AWS, one of the AWS engineers wrote a set of actions that you can use. Azure has support for actions as well, and Google Cloud. So you can go out to GitHub, you can find all of these. And there's also some vendors here at the conference that are providing actions. So the Pulumi booth, I was talking with them this morning. They have action support, and Terraform also has action support. So we might run out of time because I think I had too many slides. But I did want to mention just a few details about security. GitHub Actions allows you to embed secrets. When you're setting up a workflow, there may be certain passwords or usernames or things that you don't want to check into the repo, but the workflow might need to access them to do something useful. And that's where secrets come in. So within the GitHub UI, you can click the Secrets tab. And then from there, you click Add a Secret, and then you set up a name and value. And this is useful, particularly if you're like publishing an open source library, you need to publish to Maven Central, you're going to need to sign your artifact, you're going to need to authenticate to Sonatype so you can get the library published. I just realized I'm going to run out of time, so I will skip to final thoughts here. This thought is straight from Continuous Delivery book. Continuous integration is all about providing rapid feedback to developers. Hopefully your build will execute quickly. Hopefully it'll give you the feedback whether your changes pass the test suite or don't pass the test suite, or maybe you have some linting tools that are checking for other attributes on the code that you've got in the repo. But as the book says, CI is not enough. You really need to think about more than just building your code. You need to think about the whole end-to-end thing. You need to think about how are you releasing that code to your users. Because at the end of the day, that's all that matters, is making that code available to your user base. And so in conclusion, I'll just say GitHub Actions, I've been using it for a couple months. It's worked really well. Been using it mostly for Scala and Java projects. Seems to be pretty solid for those things. But beyond CI, if you're working in an enterprise and deploying customer-facing code, you need to think about just the whole pipeline all the way through. And hopefully, if you do that well, you can deploy with confidence. So thank you for coming.
Our first question, of course, is what challenges are you facing in this area? And because you're the first to sit on the stage, Joe's going to put a mic in your face.
My question is how much reuse others are finding in systems other than GitHub Actions with their CI and CD systems? How much do you borrow from an adjacent team or an adjacent company or another place? So I actually want to step away from Actions to ask that question.
Yeah, great.
So do I answer that question, or do I make my own question?
You can answer that question, or you can share some challenges that you're facing in this area.
All right, I will share the biggest challenge that I see in that area. GitHub Actions combined with a project that I saw from Google called Tecton, and another project I saw from Intuit, of all places, go tax people, called Argo, are the first projects that seem to distill the problem down to a point where you can remove a lot of the tech. And yes, there's Circle CI and other things, but they've actually been able to capture the essence of what people who are actually running tests want to do. So I really think that that's like the hardest problem, and that's the biggest challenge. I'm glad they did it.
Yeah, so if I can answer the question of what can be reused, I just spent the last few months working on GitLab runners, which is more or less, I mean, it's the same thing, it's a pipeline. And what I found that is in the end, by creating, and I'm not actually sure this is a good idea or not, but I created a container on my laptop which had all the appropriate tools that I needed for my development, and then used that same container up on the pipeline so that every time, then used whatever I wanted to develop. I mean, I had my own editor, I have my own personal configuration, but it means that once I commit my code up to the pipeline, I now know that I have exactly the same thing on my laptop and in the pipeline, and then I run all my different linting or creating, using the infrastructure as code or whatever I'm doing, it's all exactly the same. So even though there might be different people with different projects, they can all have a same base of tools that they're using.
Yeah, so to this gentleman's question about reusing things, we're using Jenkins for a lot of our CI work and CD work, and we discovered patterns being reused, or we were doing things ourselves. So Jenkins has a nice simple way of sharing secrets, just sticking them into environment variables, which doesn't work for various things. So we then had little groovy libraries that say, okay, we'll take these environment variables and drop them into a file in this format. So that tool can take it and manipulate them in different ways so they fit in. And we now have this growing library of groovy code that allows us to do all of those in our different pipelines.
And almost like a key store, just to clarify. So is that almost like a key store? You said it pulls out secrets in particular cases. I just want to make sure I understood you correctly.
Yes, so we use Jenkins' built-in secrets management, which can be Vault or it can be itself, and then we manipulate them to fit into what we need. So in our case, it's writing them onto disk so that GPG can import them, or putting them into a Git credential store so that we can actually run Git in the job, but not under Jenkins management. So yeah, it's manipulating the secrets wherever they come from.
Thanks.
What other challenges? Any other challenges folks are facing? Yeah, I'll come to you even.
So a challenge I have with all of these tools is development of the pipelines themselves can be very tedious. I find myself doing a lot of commits that say testing the Jenkins file or testing the Circle YAML file or now testing the Actions file. Any folks have success in coming up with alternative ways to testing the build out of these tool chains?
So actually, this is a common thing, and so with GitHub Actions, you can build local. You can actually run that same piece of whatever locally, and like the gentleman over here says, he packs it in. I was curious if he actually tests that thing and had its own workflow, but test locally, but think small. Create steps. Steps are cheap. A lot of people will try to put everything, build, test, push, screw the world all in one. Split those out in a separate one. Screwing the world actually needs its own separate step. So just think about it that way.
So I can respond to that in terms of what doesn't work, which is the temptation to put everything in a nice little bash script and then run that from inside. Yeah, you're chuckling. Because you don't surface any of your errors really well. And I've been a dev on platforms like this before and trying to capture the logs and the output from those bash scripts and also the exit codes and surface them accurately is really hard. So it can be easier in the long run to just suck it up and make sure your YAML file, whatever platform it is really accurate and pretty verbose versus just like stick in a bash script and then run the bash script. So.
All right. We are at time to move on to our next question, which is this. What successes have you had in this area? So what successes have you had around automating your pipelines, either with GitHub Actions or elsewhere?
Sort of a mix between why the bash stuff is bad, but successes elsewhere. Switching to structured logging for your test outputs is actually super useful, because then you can run tools that can actually extract out, hey, here's the error, with something a little bit more robust than a regex. Like, oh, it said error. Like, it said there are no errors in this file. Oh, that's clearly that's clearly where things have gone wrong, not 10 stages later where there's a stack trace. So structured logs from your testing and your CI tools are really useful.
So we have the start of a success story in that we deploy to multiple regions in multiple clouds. And whenever you're working on something, you're typically pointing it at one region in one cloud, and you say, yeah, that all works fine there. And then we've got to the point where we now are able to automate the testing in multiple regions and starting in multiple clouds. So you get feedback on a PR to saying, yes, that works there, or it doesn't work there. So you don't find out at the point of delivery, you find out earlier on. Which cues up the next question that I might have, is Jez and David Farley, they talk about continuous integration being about the master trunk and not about PRs. And I'm interested in if that's the only model we should consider, because we find ourselves doing a lot of work on PRs and branches for code that changes mutable things. In our case, it's Terraform for infrastructure as code. But I see the same patterns in when we deal with databases. This is something not necessarily the end artifact. There's a mutable piece of data at the end that I don't think a single branch works for. You need to be able to see something mature before it gets applied.
Okay, very good. So relating to the question of what successes had, and also to that note, so Sean alluded to this a bit. I've had successes with pipelines by using the Git idioms to drive the pipeline structure, so that instead of having one pipeline with conditionals or a lot of like branching logic, instead I'll have one pipeline that runs on some kind of branches, another one that runs on other kind of branches, one that runs on pull requests, depending on what the code means in those different areas, and then on commit to master, then it runs the deploy to prod, so that the sort of the provenance and the logic of the code is reflected in the code instead of being kind of buried in the pipeline.
We've talked about how to use the technology or appropriately scale it, but I think one of the other elements to think about is who's using it, it's the humans behind it. And I found a lot of value in expanding the idea of using this to the documentation and to the supporting functions, not just people that we call core devs. So what you're doing is kind of ruining the idea that there's a shaman or a wizard that knows it, and you're spreading the knowledge a lot wider, so you have more experts to go to. And the more that you get that used, you end up with more reusable patterns, because your documentation and your supporting folks also have domain knowledge. So that's been another vector for ease of use besides just the troubleshooting that we've heard.
I want to just say, in terms of the continuous delivery thing, I don't think that continuous delivery says don't automate pre-submit tests on a pull request. I think that that's probably still very useful. But the idea is that you don't have sort of long-lived things that go off and don't get tested until they land in main. If you have 10 branches and they're all well tested, I'd really say, hey, you're continuous delivering 10 branches. And in our project, we actually have like 5 branches we need to keep taken care of, because we cut a release and then people are wanting to use that release, but our head has moved ahead. So when we need to backport a fix, we want all our tests to run against those branches too.
I have something that sounds really simple, which is use the tool. And by that I mean, so I work in consulting, and the number of times I've seen companies reinvent a wrapper over a tool to either protect the developers from, like, we don't want them to have to learn something new, or we don't want the devs to write YAML, so we're going to write our own tool that translates our own YAML file, usually, into this other YAML file. Like, is ridiculous. And you'll be chasing your tail whenever you do that. And also I see that a lot with, like, we're going to write an in-house wrapper to work against all 3 cloud providers or 2 cloud providers or whatever. And again, you're always going to chase those cloud providers, and you lose the ability to leverage what makes each of those cloud providers unique. So I know oh yeah, exactly.
I said at least the documentation will be worse because you wrote it yourself.
Yeah. Oh yeah, exactly. I mean, you'll have written it yourself, but you'll hate yourself. So
it's all turtles all the way down.
All right, well, let's stop making things worse and imagine that we're all magicians and we have this magic wand. So in 2 to 5 years, what do you want to see in this space or in this area? And specifically, I would encourage you not to think about what are you going to build in the next 2 to 5 years to make things better? Imagine someone else with infinite resources is off building this thing. So it is truly magic. In 2 to 5 years, what do you want to see? We'll start there.
Not aligned with the brand, but a concept, much like we have great logging frameworks and testing frameworks and web application frameworks, and then we build a value layer on top of that. I think much of what we do in the CI and CD space, we reinvent as we go from job to job. So what I like to see as a theme is that we have foundational pieces, code, concepts, patterns, frameworks, templates to pull from that get us to the 60, 70, or 80%, and then we're building a value layer on top, not reinventing at each job that we go to.
Something I don't want to see anymore is all this YAML. I should say YAML is a data structure that is, kind of like a flat thing that just sits there and is not actually all that appropriate for representing state changes that happen in the course of CI/CD. So I'd love to see us develop a shared open source higher level language that really fits for describing CI/CD pipelines.
So one of the patterns that I've been happy to see starting to grow is having all of your CI and CD definitions in your repo alongside your code, as opposed to off in, like, oh, it's living in Jenkins over there, and maybe that's source controlled somewhere else, but it's not immediately obvious when you're accessing the code where the tests are or how they're configured. So I want to say good job on GitHub on that, good job on Circle and Travis. Build more tools like that.
I'll just put in one thing, having the Jenkins, since you talk about Jenkins, having the Jenkins file in the source code repo, I have a thing that will spin up Jenkins locally and execute the job on my laptop in a Jenkins instance before it even goes to the real Jenkins.
Who else in your company has that?
Nobody wants to heat up their laptop that much.
All right, any parting thoughts, questions, or words of wisdom from anyone in the room? Yes.
I just thought of maybe it's not really small, a small 2 to 5 year thing. I would love an actual validator for all of, like, Terraform or CloudFormation that not just, like, does your YAML pass specs, but as this came up in a previous session, as our infrastructure gets more complex and takes an hour or 2 hours to build and tear down, you find out an hour and a half into it that you don't have permissions to deploy the thing. So something that would actually do dry runs on all the API calls that are going to be made in your template or whatever to test that you have the permissions, that the values are actually valid for those for the APIs that are being called. Not necessarily germane to this, but I totally want that.
So you want those APIs to support a dry run flag too?
Say that one more time.
I was saying, so you want those cloud APIs you're calling to support a dry run flag so that you can do that testing. Now it's not so small wish.
All right. We will not belabor the meeting just because it says so on the calendar then. So what I would like to ask for is another round of applause for Sean.